Well, hello everybody. Today in this short video, I will introduce how to design the choice scenarios for supplier selection choice model. So before I begin, I will give you it's called helicopter view of the whole choice model. So as you can see, it's start with the attribute and level identifications. And usually in the research, this could be from literature and complemented by expert. So levels here, we mean, for example, if we have a price attributes, its level actually, it may come only two, for example, high and low. It may come high, medium, or low. This, we mean the levels. It's features for that attributes. And actually, this is a basic for building the choice scenarios. Without levels, we cannot build the choice scenarios. So the next step will come building choice scenarios. And this actually, there is a lot of details on this one, so I will introduce it here in this video. Then we have to verify. So for example, if we have 6 attributes and 3 levels for each attribute, the combination, unique combination of choice scenarios, it will come 729. So therefore, we have to use an optimization algorithm to reduce this number of choice scenarios. And later on, we have to verify that we got an optimized choice scenarios. So then we have to develop the survey and collect the choice from the respondent. And later on, we go to multinomial model estimation here, and we will go through internal, external validations. So design of choice scenarios is a key methodology for collecting the stated preference data required for multinomial estimations. Design of experiment provide a systematic methodology for construction the actual choice task scenarios shown to respondent in a survey instrument. Design of experiment ensures that the different attributes and their levels are combined in a structured way, rather than randomly, to maximize the statistical efficiency of the data collected. So generally, there are two methods for developing the choice scenarios. The first one is called full factorial design, and the second one is called fractional factorial design. So the full factorial design is actually the all combinations possible for each attributes and their levels. So as I said before, if we have 6 attributes and 3 levels for each attribute, the full combination, it will come 729. So just imagine that having this number of choice scenarios, it's impossible to collect data about it. So therefore, we have to go to the fractional factorials. Now, I will not go in detail on this one because this one, the basic for Cartesian product of two sets of attributes. For example, if we have A and B, and we want to get the unique combinations, so we'll go for A1, and it will just combine for all levels of attribute B. And there we go. So we have here 1, 4, we have 1, 5, we have 1, 6. And then we will go for the 2, A2, and again, we'll combine it for all attributes level of B. 2, 4, 2, 5, and 2, 6, and the same thing for the third level in A. So as I said, we have to go through fractional factorials. And the most used one and the most efficient is called d-efficient fractional factorials. Basically, there are 3 types of fractional factorials. This could be randomly. So if you have a full factorial combinations, just the algorithm will, or you will pick a random choice scenarios from the full factorials. But this is not advisable, because you will not get the information. There is no basic for selection these two scenarios. So you have to have a good justifications. And also there is orthogonal, which is very old, although it's quite usable for some cases. But I recommend here to go to the efficient design, and basically for the efficient fractional factorial design. So in my study, I chose 18 choice scenarios. Why I choose these? Because there's statistical requirement. For example, if we have 18 choice scenarios, we can have 6 tasks. Each task have 3 alternatives. This will bring the total number of choice scenarios to 18. So it's quite useful. And also in terms of efficiency and size, so we have to get the balance. And also we have to consider the respondent. Just imagine you have a lot of choice scenarios. You are at the decision maker. It's very challenging you to have an informative decisions. So that's why we have to get to the optimized one as minimum as possible. Although there is some limitation. For example, you have to get at least the choice scenarios at least as equal as the parameter you want to estimate in the multinomial estimations. Is called coefficient or beta value. So in my study, I have 12 beta values and I have 18 choice scenarios. So that limitations I tackle it, or I have no issue on it. Well, why we invest in design efficient of choice scenarios rather than increasing the sample of the respondent? There is an interesting study done by Rose et al. In 2009. So this study actually, as you can see in the figure to the right, or I will start the figure to the left. As you can see, the investing in the numbers, it will bring very less amount, a very less amount in decreasing the standard error. So our goal here to decrease the standard error, but as you can see, investing. So if we have very huge, for example, I will say 1,000 respondents, you can see if you just continue this one, again the reduction in the standard error is quite less. So in the figure to the right, you can see we have the same n, which is almost 20, but investing in the design efficient, see, it will come a large reduction in the standard error, and that's what we are looking for. So, well, there is two famous algorithm for optimization of design of choice scenarios from the full factorials. The first one is called coordinate exchange algorithm, and the second one is called Fedorov type exchange algorithm. Actually, this embedded in the software. For example, in our software, the algorithm coordinate exchange algorithm is embedded in, it's called CEA function under the IDFix package in R, and same thing for Fedorov. What is the optimization technique for those two? I will go straight away to this figure. So as I said, we have a candidate set, which is the full factorial design, and we have to get input. We have to specify some input for the algorithm. For example, we say choose 18 optimized choice scenarios. For 6 tasks, in each task there is 3 alternatives. So what algorithm is? First of all, it will pick a choice scenarios from the full factorials. Here, say we have 18 here. And what's going on? Here, a lot of mathematical equation here. It will calculate the weightage of that 18 choice scenarios, and then it will calculate what's called Fisher information. So how much information we got there, and then it will calculate the determinant of this equation, which is Fisher information, to calculate the D error or D efficiency. So our goal here to decrease the D error. Now in the next iterations, the coordinate exchange, it will swap only one level in one choice task in one alternatives, and it will recalculate the D error. If there is any improvement, it will keep these changes and it will go to the next iterations and so on. So here are some equations for optimization. So this is actually the Fisher information. It is a function of the attribute level and the weight is actually based on the probability of the alternatives. So then we calculate the D error from this equation. I will not go in detail on this one, although this one is not required to have a clear methodologies in your research, for example, but it's good to have an idea what's going on behind the scene on this optimization algorithm. So then we are ready for optimization. Before to develop the choice scenario or the survey instrument, we have to verify the choice scenarios. There is actually, I haven't seen some researchers do this one, but I suggest you pick a random 18 choice scenarios and you calculate the D efficiency, and it should be less than the one you got. And you can implement this one for certain iterations, just to be confident that the choice scenarios you have got from the algorithm is the better one. So then you have to develop a choice scenarios in a survey. For example, I used here Google form. So it's a simple task, but you have to target the construction profession, for example, in my study, and it's depend on the context of your study. So you have to strategically collect the data from the respondent, because this one it will affect your model. If you have a wrong, maybe it's not correct or wrong, but if you have data collected that is well present the decision maker utility, so the model you get later on, it will maximize the utility of the population you are studying. So it's a simple task. You just pick one up. For example, I will choose this one, and I will go to the next one. And this. So we have 6 tasks. In each task, as you can see, we have 3 alternatives, and we have to just evaluate these 6 attributes. For example, price here for alternatives A is below average, so that one is good for me. For example, and I will go for the quality consistency. I will go to delivery reliability, capacity and fleet, and so on. So after collecting the data, it will come in a form. You have to make this one. If you not get the same output from the Google form, you can just do some coding and combine 2 tables. At the end, you will upload this one to the multinomial logit estimations, and it will calculate the coefficient of each attribute. And what we mean by coefficient, it's the significance of that attribute. For example, price, how much price is important for the participants. And this one, it will calculate it for all data collection, not only one. And there is a huge optimization technique for estimation, and I will plan to do the next video on the estimation technique, especially for multinomial logit. Thank you for listening, and I hope I explain well how to implement the stated preference choice scenarios, especially for supplier selection. Thank you very much.